So remember, what we just did for that activity, right, is we tore off our corners and we put them together, okay? And so what those are called, those little angles, those are called interior angles, right, because they are the angles inside the triangle. And so we're going to write the interior angle sum of a triangle. Okay? The interior angle sum of a triangle is 180 degrees. That's our first little fact, right? That's what we just saw, okay? If we tore off all of the angles of the triangle and put them together, they add up to 180 degrees. Okay? Yes?
I don't understand how that makes a line. That is not a line.
The three angles? Well, here, I have a previous example, so let me just show it to you here. Okay? How all three angles together make this flat side right there. Do you see it?
Yeah, I didn't understand because it was like, I was looking at the wish list.
Oh, okay. Yeah, obviously we're going to ignore this. But the three angles, when we put them together, make that straight line. So that's where the straight line is. Do you see it now?
Yeah.
Okay. Thank you for saying something, Jade. Okay. So, in addition to that, and we're going to use that fact, so keep that in your mind, there's actually a more general formula we'll use when we get to like quadrilaterals and other kinds of polygons, right? But for now... Okay. We will get into that later, though. We'll do a more general kind of formula. For right now, we'll just stay with the idea that the interior angles of a triangle add up to 180 degrees. All right, so let's get into the actual classifying of triangles, though, the naming of them, the describing of them. Okay. And you may have already seen these names before in previous geometry classes. We'll see. The first way we're going to classify triangles is by their sides. Okay, by their sides. On a pencil? Let's see here. Okay, let me get started right in here first. So this first triangle I'm going to draw. Okay, try and draw as best I can. We're going to label with these little three tick marks like that. Okay, can someone raise their hand and tell me what do those three little tick marks indicate to us? Right hand. And there. Yeah, who else?
They are the same.
Yes, all three sides are equal or the same. Okay? And so since all three sides are equal, this is called an equilateral triangle. Okay? In the word itself is the meaning. Right? You guys maybe know from football that when you do a lateral throw, a lateral is to the side or behind, right? So lateral means side and equa means equal, so it's equal size. I mean, literally, it's in the word there for you to know. Okay? All right? Besides equilateral, we can also have triangles that have two congruent sides. I'm just going to draw it in a different kind of orientation here. So two congruent sides, like this. All right. Does anyone remember? Raise your hand and tell me what this is called. Anyone remember? Yes, Ramel's got it. It's isosceles. Okay, isosceles. Now, an isosceles triangle, okay, has two congruent sides, and we call those congruent sides, these are called the legs. The congruent sides are called the legs of the triangle. Okay, those are the legs. Okay, and this side here, the third side that's one of the non-congruent side, that's called the base. Okay, now, some of you maybe look at this and you say to yourself, Mr. Meyer, that's not on the bottom, why do you call that the base? Okay, we have to kind of get away from the idea that the base is always the bottom of the shape, right? It can, if we turn the shape, then the base moves with the shape when you turn it. So the base in the isosceles triangle is just the non-congruent side. That's what we call it. We'll get into more about what the base is, but when we get into quadrilaterals and stuff like that. These two angles here are called the base angles, right? Those two angles there are called the base angles. And what do you think is going to be true about those two base angles? They're going to be equal. Exactly right. That is a property of isosceles triangles. We'll look at that later, though. Now, okay, one more name in here. This top angle is called the vertex angle. Okay, vertex angle. So isosceles triangles have a lot of names. Okay, a lot of little parts that we call it. Okay. All right, so you guys can probably figure out then, our first triangle here, equilateral, has 3 equal sides. Our second triangle here, isosceles, has 2 congruent sides. So what's our only other option still for sides? No congruent sides. No congruent sides. So I'll go ahead and draw a picture of that. It's going to look something like this maybe. Okay. Sorry, I went a little too far. That's why I scratched that piece out. Okay. And so this third triangle, and again, Ramel, do you know what this one is? Do you remember this one? If you can't remember, that's okay. Does anyone remember what a triangle with no congruent sides? Oh, not in English. What is it in Spanish? Oh, okay. So scalene. So there you go. It's very similar, right? Scalene. Okay.
What is that little thing in your
This right here, that's just a mistake. I drew it too far. So, yeah, sorry. I just made a mistake and I tried to get rid of it. And I was like, yeah, people are going to think that's part of the picture. Sorry about that. Okay, the other way we can classify triangles is by their angles. Okay, the other way we can classify triangles is by their angles. So, we'll kind of go in that same kind of order here. Okay, I'm going to draw another triangle. I'm going to mark it this way, because now we're talking about by the angles. Okay. Now, if you look at this triangle and you look at this triangle, yes, I drew them freehand, right? So they're not perfect, but they look pretty similar, don't they? Okay, and so what do these little markings mean in my triangle? All the angles are congruent or the same, exactly right. And yes, in this case, they are acute as well, that's true. But the markings mean that all these angles are congruent. And so if we called a triangle with equal sides, we call that equilateral. Well, what do you think we're going to call a triangle with equal angles? Equiangular. Equiangular. Okay.
They must be equal.
So equal angles. Okay, so equiangular is the name of that triangle. Now, if a triangle is equiangular, what do you think we'd classify it by its sides? How would we classify it by its sides, do you think? If we know a triangle is equiangular, how do you think its sides will be related? That would be equal as well. So an equiangular triangle is also going to be equilateral. Okay, an equilateral triangle is also going to be equiangular. And if you have a shape that's both equilateral and equiangular, we call it regular, which to me is the most silly, like so silly to call something so special regular. But anyway, that's what it is. All right, next one. Sorry?
How many is there?
How many? There's going to be 4 total. So just want to make sure you have enough space. Okay, so I'll draw another triangle here. Okay, in this triangle, all the angles are less than 90 degrees. So guess what we call this triangle? Acute. It's acute. Okay? It's just an acute triangle because all the angles are less than 90 degrees.
What is the first one?
Equiangular. Equi, and then the word angular. Okay? All right. Now, in this triangle, it looks like we have one, what kind of angle? Right angle. But then we have 2 other acute angles. So should we call this like a right acute acute? And no, all we do, this triangle is called a right triangle. It's called a right triangle because it has one right angle. Okay. Can you have two right angles in a triangle?
Yes.
See, if Mr. Meyer just pauses long enough, everyone like starts to doubt themselves.
Wait, what? Wait, what?
Can you have two right angles in a triangle?
Yeah.
No, you may not, because a triangle usually only has one thingy.
Has only.
It would turn into like a rectangle.
Yeah.
So right, imagine trying to draw that thing. Right, if you were to draw one right angle, either we'd have to put the right angle up here, or we have to put the right angle down here, and it's like that triangle will never meet, right? Because what's going to be true about these two sides? They're what? Parallel. They'll never meet. Okay, so we can't have a triangle with two right angles, except there are other kinds of geometry where you can have a triangle with two right angles. And if you're interested, I'll talk about that later or something like that.
Cut a square in half.
Well, if you cut a square in half, you cut the angles in half too. There's other kinds of geometry, and I'll explain it to you guys later. It's actually pretty easy, where you can have more than one right angle in a triangle. But you have to kind of like redefine how you think about triangles. All right, last one here. What's this got to be named? Obtuse. Yeah, no, this one's not right. It's got an obtuse angle. And again, what's the most number of obtuse angles we can have in a triangle?
90, 180.
So it's one, right? It's got to be one, okay? So one obtuse angle is what we're allowed. Again, if we have two obtuse angles, the two sides will never meet. Okay? Okay. So just a quick example here. Let's say we have triangle ABC, and let's say that segment AB, side AB, has a length of 1.5. Let's say side BC has a length of 1.3. And let's say side AC has a length of 1.8. Okay, so we don't even have a picture of this triangle. No picture, but we have some side lengths. Okay, and likewise, I'm also going to give us some angles here. So let's say that angle C is 55 degrees. And let's say that angle A is 45 degrees. And let's say that angle B is 80 degrees. Okay, so we've got those three pieces of information. And believe it or not, with only those three pieces of information, without a picture, we can classify this triangle. Okay? So take a look at that and just think about it right now. Don't say it out loud, just think about it. How might we classify this triangle by its sides? Just think about it, don't say it out loud. And how might we classify it by its angles? Again, just think about it, don't say it out loud. Okay, I'm going to call on someone here. Okay.
Are we choosing from the three up top, or are we choosing from the four that we just drew?
Well, we're going to classify it both by the sides and by the angles. Okay? So good, I'm glad you think so. Okay. Mr. Moore, I got this. Just kidding, I don't got this. I have no idea what's going on. Okay. So, let's take a look here. Gabe, AB has side length 1.5, BC has side length 1.3, and AC has side length 1.8. What of our three classifications, then, could we give this triangle? Is it equilateral? Are all the sides equal?
No.
Nope. Is it isosceles? Do we have two equal sides? No, so what's it got to be, then?
Scalene.
Scalene, exactly right. So this triangle is scalene.
What is scalene?
Okay, scalene. And then by the angles, let's go to Ryan. What is this by the angles? Acute. And how can you tell?
Because all of the angles are
Under
under 90 degrees.
90 degrees, and they're not all equal either, right? That's right. So scalene and acute. Okay. One other thing I forgot to mention here, so that's that, very good. Equiangular, so if all three of the angles are equal, what must each angle be equal to?
40.
So let's think about that. All three of these angles in this triangle have to be equal. Can we figure out what one of those angles has to be?
Wait, 3. Wait, does it have to
Haley, how'd you get 60?
Because if you have 60 for each angle, then all that.
Exactly right, right? So if all the angles in the triangle have to add to 180, and they're all three the same, 180 divided by 3, 60. So exactly right. All the angles in an equiangular triangle will always be 60 degrees. All the angles in an equilateral triangle, therefore, will always be
60 degrees.
60 degrees. That's right. Okay? So for sure. So good job there. Yeah, that's right. Okay? Cool. So let's just go around the room here. We're gonna do a little practice. I'm just gonna call on people. I'm not gonna get this worksheet out because it just seems kind of silly making all these copies. We're just gonna do some here. So we'll just start out. All right. So looking at this picture. Okay. Let's go to. Oh well, Haley's already answered to go in there. We'll go Ikeba. What do you say, Ikeba? I know it's not marked, but if you were to guess by its side, equilateral and equiangular. Very good. Beautiful. Thank you. Xander. How about this one? What would you say this one is? Again, it's not marked, but what does it look like it's going to be by its sides? Okay, so you think all three sides are different? Yeah, two are the same, so that would be isosceles, and then by its angles, what we call this? No idea? Okay, Jason? It's probably a right triangle, because that looks like a right angle to me. Granted, it's not marked, but it looks like a right angle, so it probably is. Okay, all right, let's go to someone else here. Let's go to Derek. How about, let's go to this one, Derek. What do you call this one? By its sides?
Equilateral.
Equilateral, and by its angles?
Equilateral.
Beautiful, very good. All right, let's go to Jordan here. How about this one? What would you say by its sides here? What would you call this? By the sides. Okay, so that's the angle, it's right. Yep, so it's a right angle. But then, which one of the sides there? One of those three, which one? I would say scalene here, yes. It doesn't quite look isosceles, so I would say scalene. So very good, right? Scalene. Okay. All right, how about this one? Let's go to Zaria. Zaria, by its sides, what would you say that one is? It kind of looks equilateral. Yeah, I would say maybe equilateral there. And so therefore, by its angles, it must be equiangular. Equiangular. Okay? All right, I'm going to skip some of these because some of these look kind of the same. All right, let's go to Jason. Jason, this one, please.
That one is going to be
Isosceles. And by its angles?
acute.
Acute one. Very good. It's a cute triangle. Okay. Let's see here. Krishna. What about this one, Krishna?
Obtuse and isosceles. Oh, no, scaling.
I'd say scaling. Yeah, it's hard to judge, but I'd say scaling. I'd say scaling. Hard to judge, but I'd say scaling. Okay? All right, Ramel. By the sides, what would you say? I'm sorry? By the sides first, please.
The side?
Yes, name it by the sides. So again, your three options are equilateral. Don't look over there. Look up here, Ramel. You got this. Yeah. So equilateral, isosceles, or scalene. Which one of those three? Equilateral, isosceles, scalene. Scalene. Yeah, it looks all three different. And then wait, Ramel. What's by the angles then? By the angles, is it equiangular, acute, right, or obtuse? Derek? It's acute. Thank you. Thank you. I know, you were trying to trick him, Derek, and that's mean. All right, Maddie! How's that one? So if it's equilateral, that means the angles have to be what?
Equiangular. My bad.
But do you understand that, though, Maddie? Right, okay. So it would be equilateral, equiangular, okay? And Derek, yes, please give other people an opportunity, okay? If you got it, that's great, but give everyone else a shot to get it right as well. All right, last one here, Garrett. What do you say? Okay, scalene. I can maybe see scalene. I can also see potentially isosceles. Again, it's not marked real well, but yeah. And right. Very good, that's right. Okay? So there you go. Very good on that. All right.
What kind of angle is that? I'm here.
This one right here. Are you asking about this question?
Yeah, what angle was it?
This would be a right triangle because we have a right angle there in the corner. Okay? All right. We're not quite done yet, okay? We're going to go into our books real quick. Oh, no, Mr. Wade, oh, no. Okay. So if you would, please open up to page 140. Okay. Please open to 140. And don't worry, we will breeze through this. 140, though. Okay, page 140's, page 140, pages 140 in your book, page 140 in your book. Explain 1 is where we're going to start, right here. Okay, page 140. Okay, page 140. We're going to look. Is it in your desk? That could be it. Okay. So page 140, we're looking at this, okay? And this is super straightforward. In fact, it's something we kind of already know, but I just want to make sure we hit it just to make sure we're okay, okay? So we're going to finally, really kind of break down congruencies, okay? So we're going to talk about corresponding parts. Remember, we've seen that word corresponding before when we talk about parallel lines. Remember, corresponding angles were kind of in matching positions, right? Matching positions. So we're going to talk about corresponding parts. And those are just matching parts of congruent figures, and that means that they're congruent, if they're corresponding. Okay? So, if two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. Okay? So let's take a look here at a congruent statement. Okay? We saw this in our test, and we're going to see this more as we go throughout geometry. Okay? Shh. Focus up here. Okay? And don't look, Ramel, and then you won't know. Okay? Ignorance is bliss. Shh. Okay, so we have this congruency statement. Now, this statement is more powerful than you might recognize, okay? When we say triangle ABC is congruent to triangle DEF, and then here's their pictures right here, okay, we mean more than just this triangle matches this triangle. This is actually more powerful. For example, you see here A, okay, is in the first position. And over here in this triangle, D is in the first position. That means that angle A is congruent to angle D because they're in the same position. So A and D are going to be congruent or equal, right? Angle B will match up to angle E because it's in the second position, and angle C and angle F also must match up. But it's more than just the angles. This also labels the sides as well. Okay? So for example, side AB, what does that have to match up with over here in this triangle?
Side DE.
DE. Okay, right. BC matches up with EF, and then AC, side AC matches up with side DF. Okay, so all those statements are contained in this one statement. All those congruences, all those equalities are stated in one statement. Okay, so for example here, if we want to find the measure, it says find the given side length or angle measure. If we want to find the measure of DE, what can we look to? What else does DE have to equal? AB. So if DE is what we're trying to find, AB we know is 2.6, so therefore what must DE be? 2.6. Okay, in fact centimeters, right, because that's the measure there. Super simple, right? Okay. Let's see here, angle B, the measure of angle B. Okay, well what do we know angle B has to match up with in the other triangle? Angle E. So, 65 degrees. Okay, super simple, super straightforward. Yeah, not bad at all, right? Okay, so let's also look here at the next page, page 141. It gets just a little tricky, thank you. Ramel, this is for you, buddy. Okay, well, we'll get the scissors, I promise, but it's for right now, too. Okay, I'll get them, Zaria, if you don't mind holding on to it just for a little bit longer. Okay.
Oh, I know.
So now, yeah. Leave it here, and if you are late or something, I'll write you a pass or something, okay? I'll watch it for you, I promise. Let's skip over to the bottom of page 141 here, okay? You'll notice we're given a similar congruence statement, and we're asked to find the given side length or angle measure. Now you'll notice here, though, we see some variables show up, okay? So now we might have to set up some equations and solve those kind of things. So we want to find side AB. So here's side AB, and it's labeled as 3x plus 8. Well, we want to come up with an actual measure here. So 3x plus 8, side AB. What other side does that side AB have to match up with? I'm going to pick someone. Hang on, I'm going to pick someone. So let's go to Chardez. So what does AB, according to this statement, have to match up with? D. So there's AB. So DE. So that means AB here, 3x plus 8, has to be equal to what over here? Sorry. It's over on the next page over. I think we're on page 141 now. Sorry. 5x. So we're going to write 3x plus 8 equals 5x. Okay? Because that's AB and DE. They're equal. And now we have this equation we set up, and we're going to solve that equation, right? So, Chardez, what would we do here to both sides to start solving? You got it, Chardez. That's right. Minus 3x from both sides. You get 8 equals 2x. And then last step there, Chardez. Divide both sides by 2. So we get x is 4. So, Chardez, are we done? Is that our answer? Is AB equal to 4? No. AB is equal to what? What's it labeled as? What's the measure for AB, though? 3x plus 8. Exactly right. Now that we have what x's value is, we can plug the 4 in for the x there. So it's going to be 3 times 4 plus 8. 3 times 4 is 12, plus 8 is 20. So the answer is 20. Okay? So 20 is the answer. 20 inches, right. Yes, we should use our units there. Good call. 20 inches. Okay? So that's the idea, okay? We have to set equal things to be equal, and then we solve for that variable. Okay? Questions on any of that? All right. Let's do one more here. Let's do angle D, because it says to solve for angle D on the other side. Okay, so we'll do angle D here, and then we'll stop. All right, so let's go to. All right, so Garrett, let's solve for angle D. Okay, it's actually on the other side, but I don't want to turn the page because then we'll miss the picture here. So here's angle D, and according to this picture, what is angle D's measure? What's angle D's measure? According to the picture, Garrett. Sorry, I just want to make sure everyone's okay in the back there. I hear lots of gasping for air, so I want to make sure no one's dying. No, but again, we're talking about angle D is what we're going to solve for here. So what's the measure for angle D? 6y plus 2. Okay? Now, what other angle does angle D match up with here, though, Garrett? What must it equal? According to my congruency statement, D is in the first position, so it matches A. What's A's measure? So that means that these two things must be equal, right? Must be equal because they're congruent.
How do you know it's not, like what if you said D was equal to B because you're moving it? Okay,
but look at the congruency statement. The congruency statement has D in the first position matching with angle A. So therefore, the way that congruency statement is written, they must be the same. Must be the same. Okay, and that's how powerful that congruency statement is. All right, so Garrett, to start solving this, what do we do to both sides? Okay, but they're on different sides of the equation, so I can't do 6y plus 5y. I either have to get rid of the 5y and move it over here, or get rid of the 6y and move it over here. So, yeah, I like to get rid of the smaller of the two numbers, so that's a good idea. Subtract 5y from both sides. So we get 1y, or just y, plus 2, right, equals 11. And then last step here, what we got to do? You got it. Subtract 2 from both sides. You get y equals 9. Okay, so are we done here? Is that our answer? Is y equals 9 and the measure for angle D?
No.
No, what's our final step we got to do here, Garrett, with that number 9? What do we have to do with that 9? Well, D's measure is 6y plus 2. Plug it in. That's right. Is that what you're going to say, Jay? Yeah, plug it in. Thank you, Jay. So 6 times 9 plus 2. 6 times 9 is 54, plus 2 is 56 degrees. So there's the angle measure for angle D. Okay? So that's the idea. Yes, Akela.
On the next page,
Yeah.
for the your turn part, how is that shape turned?
All right, hang on a second. Let me wait for a few people are just finishing up right here. 56. Yes, I'll get that to you in just a second. Okay, so yeah, this shape on the your turn is being rotated.
Okay, like how would you figure out what's the pre-image?
So, great question. In this case, since we're not given any information, it doesn't really matter which one's the pre and which one's the image.
So it's going like this, right?
But it could be going like this too,
Right, that's
technically.
what I'm saying.
So it could go from here to here, or it could go from here to here.
Okay.
What's important though, in this case, because we're not worried about transformations right now, is just that they are going to be congruent and then matching up the corresponding sides. Okay, real quick guys, before you put this away, let me give you your homework assignment, okay? So, you're going to turn to page 144, and I want you to tear out all the way to page 148. It might sound like a lot, we're going to skip some problems though, so don't worry, okay? So again, tear out 144 to 148, please. Okay, if you want to circle these problems in your pages, this would be a good idea. 144 to 148, numbers 1 through 13, 19, 20, and 23. Okay? Yes. Page 144 to 148. Okay? That will be your assignment.